Hey students, just with a quick video here. Hopefully the sub has already given you this paper for the notes, but definitely wanting to get you into this new idea here. We're going to take a look at congruent figures and looking at their angles that are congruent and sides that are congruent based on not only the picture but more importantly the congruent statement. Okay, so we'll talk about what those are here. Looking at this paper, you can see that we have congruent figures. If I have congruent polygons, which means that all sides and all angles have to be congruent to something else, right? This last part of the last sentence is the most important. You must list corresponding vertices in the same order. So I know that mine's in color here and yours is not, but looking at this here, you can see, oh, I have an A and it's an A. Whatever angle is congruent to it has to come next. So you can clearly see by the color E is coming first, right? In both cases we move to F, right? So F would be the next one, or B, excuse me, I guess we move to the blue. So B and F would be the next. Then we go down here to the purple, C and G, excuse me, and then out to the green, D and H. You could write them in any order. For example, for this first one here, I could write C, D, A, B. I could write it in that order, right? But if I start it with that order, I'd have to write G, H, E, F, right? So it doesn't have to be in alphabetical order, right? They have to be in corresponding order. Another thing is I can't just say, hey, it's B, D, A, C. I have to go around the shape, right? So just kind of looking at it in order for that way. That's going to be the big idea for today. All right, a couple quick things here. Isosceles and equilateral. We kind of probably have a basic understanding of what that is, but it's just a triangle for isosceles at least that has two sides that are congruent. You might say the same, right? Remember this symbol right here just means congruent. But congruent is actually the word that we want to use for this class. Same idea for equilateral, except for it doesn't just have two sides, but it actually has three sides. So if you see these words, isosceles or equilateral, you have to instinctively think, make sure that you know that two sides for an isosceles and three sides for an equilateral are congruent. All right. Right here, when we're taking a look at this here, example 1, back to these colors. If we're looking at this, we kind of think about the congruent sides. Remember, you have to list them in the same order. So if I said AB, you would have to say EF, right? So sides on the outside of that. BC is another one, and if I said BC, it'd have to be FG. Right? Notice that they're in the same position, right? The red is first and then the blue. Let's see here, it's excuse me, I guess I did mess this one up. It should be blue first, right? So it should be blue first and then purple second. I can go through and list two more. Another one would be CD, so that's GH is congruent to that. And then the last one that I would do that I haven't done is AD. And we're just listing the individual sides. So that was red and green. So EH there. Angles, same idea, right? If I'm just listing them, it doesn't really matter the order. But this is what we call our congruent statement. This is where order matters, right? But as far as the angles go, it's angle A congruent to angle E. I have a four-sided figure, so I know I'm going to have four angles. Angle B, congruent to angle F. Angle C, congruent to angle G. And angle D is congruent to angle H. All right, so what I want you to do here is try this phrase. It says, try it. I'm going to pause the video. Go ahead, come back, try it, and hopefully you have a chance to pause the video as well. All right, here are those answers for the try it. Hopefully, if you need to, pause this video just to check them. All right, remember, anytime we are trying to prove congruent figures, we need to have all angles and all sides show congruence right here. All right? So let's think about this. We got two triangles here. We need to show that three sides are the congruent and three angles. So let's see if we can do this here. Angles. Let's just start with angles. Looks like E and A are congruent. Angle E congruent to angle A. Angle D and B are congruent. Angle D is congruent to angle B. And so now we need a third angle. And that's what happens here with these two. These two are technically congruent because vertical angles, right? So I could say BCA, right? Angle BCA. I'm going to put it on the right here just because that's where all of those have been done. Now think about this. I did B first, so I can't do E first. I have to do DCE. Angle DCE. All right? So keep that in mind. Order does matter here when we're listing this. Sides. Let's start out here. I went from E to D, so side ED. Notice that we're taking a look at this here. I'm going to go from 2 to the vertical angle here, so that's DC, side DC, and again 2 to the vertical angle, that's BC, right? We know that those two are congruent. The only ones I haven't done here, again starting from 1, and that should be congruent to AC, all right? So we need all sides and all angles to show congruence here. All right, on the back side, real quickly, third angles just says, hey, if you've got two angles in a triangle that are the same, for example, maybe this one is 50 and this one is 90, then don't these two angles right here also have to be the same? Right, that's what the third angles theorem has to say. All right? Why does this work? Well, we just know it that all angles have to add up to be 180. Okay? Now, sometimes it doesn't give us three sides and three angles here. We're going to predominantly focus on triangles here for the rest of the chapter, including today. But again, what else do we have? So let's think about what we already do have. We already have some angles, and we already have some sides. With that being said, it looks like RTK, that's an angle, RTK, and UTK, those are ones that we already have, UTK, that are already congruent. Looks like angle R is congruent to angle U. That's another one, right? But here's something that we need. We don't have a third angle. Okay, so the angle that we need is, I'm going to start 1, missing 2, so that's going to be angle RKT, right? Now notice how similar these two are. Order matters here, right? So that's important to know. And then with this one, we'd have UKT. So I need that third angle. So this is what it's asking for, right? It's asking for what is missing, right? That's what happens right here with what I need. Same idea with the sides. The sides, it has, we'll just do the one here first. So 1 to 2, that's side RT, and that's congruent to UT. I'm going to go 1 to the missing, I guess, and so that would be RK, and that's congruent to UK, right? And actually, we do have a third side. We need to start thinking about this right here. This side is the same. TK is congruent to TK, right? TK is on both triangles, right? We already know that, okay? That's the reflexive property, not something that we've really focused on a lot, but yes, we can still do that. All right, example 4. Basically, we're using this shape, but we're doing 4 separate problems. So every time that we move to a new number, we're going to basically restart the shape here. All right? Now look at this. This is important here. This congruent statement, triangle ABD, congruent to triangle CBD. All right? So if A is 30, so what I want to think about is that this number right here is 30. What is the measure of angle C? Well, notice A and C are in the same position, right? They both come first, so that means angle C also has to be 30 degrees. If ABD, okay, so let's start over here. If ABD is 90, so that means that this one right here is 90. Angle C is 30, what's the measure of BDC? So they're asking about this one right here. So notice the one that we're missing for both of them is the third angle, right? So I know that all three of these angles, they have to add up to be 180. So that just means the measure of angle BDC is 60 degrees. We could do the same idea with the length here. If AB is 3x minus 2, right? So triangle ABD, again just copying this down here, congruent to triangle CBD. So it looks like and maybe it's helpful to draw it here. A, B, D, and C, B, D, right? You could even see it right here, I guess would be a better picture of it. But just kind of separating it out. So AB says it's 3x minus 2. Again, we know it corresponds to CB. D is 20, and CB is 22. So basically what I'm trying to decide is which one is this the same as? Is 3x minus 2 the same as 20 or 22? Based on this congruent statement, CB is the first two, AB is also the first two, whereas CD looks like the first and the third, right? So it clearly says I'm going to have this equal to 22, right? Because they both are in the first two positions. 3x minus 2 equals 22. I could move it over, right? I could add 2 to both sides. I could divide by 3. X equals 8. And if I just plug it back in, well, we know it's already 22, right? Didn't we say that it was going to be the same as this? So we know it has to be 22. If the measure of ABD is 2x plus, or the angle 2x plus 6 and 4x minus 10, we know that we're trying to find x and this measure, right? So I'll post these notes here on Canvas. Know that this will be completed, but think about it, they're just the same measure, all right? All right, one last thing, proofs. We're going to get back into some proofs here, especially when we talk about these triangles. We have to have 3 angles and 3 sides, all right? So we'll take a look at the sides here, sides. Right, let's go see what's given. There's 1 and there's 2. With the angles here, we also need 3 angles. There's 1 and there's 2, and those things are given. If we recall from a conversation from earlier in the video, what's the reason that LN is congruent to LN? That's just the reflexive property. Reflexive property, just like you're looking in a mirror, we can see that's the exact same thing. Okay. So therefore it is. Another way you could also use the symmetric property, right? Just a little bit of symmetry with that. How do we know that these 2 angles right here are congruent? These 2 angles are right here, M in L and O in L. That's just what was at the top of the paper. That is just called the third angles theorem. Third angles theorem. And then how do we know that these 2 triangles are congruent? I know that because all sides and all angles are congruent. Alright, so here we go. After this video here, I want you to work on the MathXL assignment, just called Unit 4, Lesson 1, Congruent Figures, from Unit 4, Lesson 1, and that's on MathXL. I hope you are all well, and I hope to see you guys soon. Thanks.